into thermal energy management. Really great to have you all with us today, and also really good to see a really strong lineup of speakers, and we hope that you find the session today valuable. From the Carbon Trust side, we have Eloise Bennett, myself, I'm Southeast Asia Manager of Carbon Trust Singapore. Kartik Arunachalam, he's our Client Manager, and he will be talking you through the technical elements of the work programme, and Kalyani Basu, who's an Associate in the Singapore office. We also are honoured today to have the Malaysian Food Manufacturing Group Chairman, Yang Bahagia Dato' Anam Pawante, as well as Chin Kok Ho from Cofreth, and a representative from Petaling Jaya Dairy, Desmond He, who's a senior electrical service engineer at the dairy. So we're very happy to have these external speakers. The overview of the workshop today, we're going to start with some opening remarks from the Federation of Malaysian Manufacturers. Then I'm going to quickly introduce the programme that we are working under, the UK government's ASEAN Low Carbon Energy Programme. Then we're going to do our deep dive on thermal energy management. We have a really good guest speaker from Petaling Jaya Dairy, and then we're looking at energy management systems and how Carbon Trust can support you. I want to encourage you to use the Zoom systems to drop any questions at any point into the chat box. So you'll have a little chat button, and please drop in any questions. And during our allocated question sessions, we will hopefully answer these. But without further ado, if I could hand over to Yang Bahagia Dato' Adnan Pawante to introduce the workshop today. Thank you.
Thank you very much. So, Assalamualaikum and very good afternoon to everyone. Welcome to the webinar. I'm pleased to welcome all of you to this Saving Energy and Cost, a deep dive into thermal energy management webinar. And if you remember, this is actually a follow-up webinar from the one that we had earlier, which I understand was very successful and strongly supported. So ladies and gentlemen, renewable energy has emerged as the single largest source of new power capacity addition in recent years. The nations of Southeast Asia stands at a crossroad in terms of the collective energy future, and over the next decade, ASEAN will experience rapid economic growth and a 50% rise in energy demand. That's 50%, tremendous. With this growth comes challenges as the region strives to supply energy affordably, sustainably, and securely. ASEAN has decided to chart a course towards a sustainable, secure, and prosperous future based heavily on renewable energy. It has set out to make 23% of its primary energy renewable to reach by 2025. This aspirational target is grounded in a firm awareness of the region's wealth of renewable energy resources. It also recognizes a compelling business case, as tumbling technology costs for renewable makes access to modern energy services increasingly feasible and affordable for all, while bringing the region closer to a trajectory in line with the objective of the Paris Agreement and the UN Sustainable Development Goals. Ladies and gentlemen, I believe that today's sharing will be an eye-opening to the industry, especially on the thermal energy management, as well as the setting up of energy management systems that are aligned to best practices. I like to take the opportunity to highlight to all the participants that there's no such thing as a silly question. So don't be shy, don't be hesitate. And the beauty of having a webinar is that you, as what Eloise said earlier, you could post your question in the post box. That way, the facilitator can pick it up and your question can be answered. So once again, don't be shy. Make full use of this opportunity. In this regard, I wish to once again thank the British High Commission in KL for assisting the program activities together with Carbon Trust UK. Please gain as much possible inputs during the session. And thank you very much from me also to both British High Commission and Carbon Trust for selecting FMM as a platform to reach out to the industries in Malaysia. Thank you very much.
Thank you very much. So we're now going to I'm now going to quickly introduce the ASEAN Low Carbon Energy Programme. So as I mentioned, this is a UK government funded programme run by Carbon Trust Carbon Trust are a mission-driven organisation, and we are entirely focused on driving the energy transition. And our mission as an organisation is to accelerate the move to a sustainable low-carbon economy. We've been active in Southeast Asia and Malaysia for many years, working with governments, private sector, to make better decisions around climate change and energy management. We do all sorts of activities around policy, assurance and certification, corporate advisory. We design and run programs. We support companies implementing and implementing technology innovations and choosing the right technology. And then we are now more than ever working with how to green the financial systems. The program we are running in this region is the ASEAN Low Carbon Energy Program. This works in 6 Southeast Asian countries and focuses on green finance and energy efficiency. And we've been going for a couple of years now, and we are driving energy efficiency in particular from the Carbon Trust side, looking at building capacity like a workshop like today. Our focus in Malaysia is currently on green finance. So how can we support private sector finance, support invest in more energy efficient projects or on just greener projects in general. We're also working in particular with the food and beverage sector with support of local organizations like the Federation of Malaysian Manufacturers. And we really hope that we can provide information, tools, guidelines, and practical hands-on support on how to reduce the energy use of the F&B sector in Malaysia. And we're also supporting the Energy Commission to pull together an action plan on how to manage, how to design policy in Malaysia that's going to help that happen. So enough of what Carbon Trust is up to. I think it's time to focus on thermal energy management. But before I hand over to Kartik, we wanted to do a quick survey and get your inputs as audience members on how on thermal energy in your business or in your environment or wherever you're dialing in from today. So you'll see in the chat box and on the screen right now, there is a link to a Mentimeter. And if you're not familiar with a Mentimeter, don't be alarmed. If you just click on the link, we're just going to require you to drop in a few ideas. So if you jump into the chat, there's the link there that's been shared by Kalyani. What we are able to then do is get your opinions on a few of the questions that we like to ask about thermal energy management. So hopefully you'll be able to see now. Kalyani, give me a nod if you're able to see the Mentimeter. Fantastic. We're interested in knowing what are the key challenges faced by your organization to manage thermal energy consumption. So if you could just quickly drop in a few ideas that you face, the challenges you face by your organization. What are the key things that that you face, and then we can have a look and make sure that we are addressing them in the presentation today. So I will leave it open for a few seconds, and hopefully we can get some ideas through from audience members on where your organization is facing challenges. I hope this works. Oh, fantastic. So we're getting our first things through onto the screen, and hopefully we'll get a range of ideas coming through from people people listening in today. Interesting. So we'll keep it open for a minute or so and see if we can gather some ideas from people. Got one more coming through. Interesting. So as they come through, I think that it's interesting for us to see some key themes that come through from the work that we do in Southeast Asia and also around the world, around being able to make time enough for energy management and also prioritizing it among your other business priorities. And so knowledge and time is a key one. Again, technical expertise on where to focus and how to prioritize projects. That's another one that we see. I see, interestingly here, we see making solar thermal projects work economically, and that's all about building the business case and making sure that you can prioritize saving energy against other business priorities. So yeah, and again, someone's here is putting lack of knowledge to do energy audit. So that's really interesting, trying to build the capacity in Malaysia around energy auditing and the short-term investment horizon, the payback periods. So Kartik, I hope you're taking heed of these things and see if you can bring out any of these factors in the presentation as we go through. I'm going to move on to the next question. Thank you very much for this. Hopefully that's interesting for you to see what your peers in the industry are facing. The next question is about opportunities. So facing not on the challenges and actually on what are the opportunities for thermal energy saving. So what would you say is the areas where you can save the most energy and cost in your thermal energy operations on your site, or just from your knowledge of the sector or the industry? Let's see if this one comes through as well. Oh, I think I need to open the, here we go. There we go. I think you should be able to type now. We have our first one, which is recovering waste heat, and we agree with that one for sure. Kartik, I'm sure that's something that you're going to touch upon in your presentation in terms of where there's economic savings to be had. Any more? Any more that you can add? Any opportunities around thermal energy that you can add to the? Here they come. Fab. We're coming in thick and fast now. So interesting, there's a lot of different ones. We have a lot here, waste heat and waste. And you can see them all coming in nice and thick and fast. It's good also to see some less obvious answers in terms of alternative technologies like heat pumps as well, which is also something that's growing as an opportunity around the world. And the ones that are a lot more about, not necessarily about technology and about just management, so process optimization as well. Fantastic. So hopefully that gives you a good spread of where the audience thinks the opportunities are in thermal energy. Great. Well, with that, I think your work is done now, so we can hand over to Carbon Trust and to Kartik, who can talk you through the thermal energy presentation that we have today. Thanks, Kartik.
Thanks, Eloise. Good morning, everyone. A lot of interesting pointers were raised during the survey. It's a very good way of getting the thoughts flowing and seeing if we can touch on some of those pointers in the presentation ahead. But if you have any detailed questions, please feel free to chime them in on the chat box, and then we would pick them up as necessary or as we have time. Yeah. So starting off with the overview of why we have this drive for thermal energy management in the Malaysian food and beverage sector. So Malaysian food and beverage sector and also many of the process industry sector relies largely on natural gas as the heat source, compared to the other regional countries, which to a certain extent use coal and also oil. But in Malaysia, we feel that there's a strong reliance on natural gas. And thermal energy is one of the key energy consuming energy stream that is being consumed in the food and beverage sector. In the plants that we have conducted audits on in the F&B sector in Malaysia, we have found that thermal energy makes up more than 60%, in some cases even 80% of the energy consumption. And if it were to go through the business as usual scenario, without strong focus on energy efficiency or thermal energy management, the sector would continue to be, at the most energy intensive, one of the most energy and carbon intensive sectors. And also its reliance on natural gas as a heat source will continue to increase over the coming decades. Some figures to put this in perspective: total GHG emissions from the F&B sector contributed to 2.18% of the country's total emissions. And that is quite a substantial number when we talk about overall emissions. Next slide. So, we have conducted multiple rounds of this workshop. So we wanted to put this into a better perspective, be creative about how we want to present opportunities to improve thermal energy management in the food and beverage sector. So we came up with 4 so-called categories of areas. So first is energy management information systems. You can't improve what you can't measure. It's a cliche statement by now. Improving operational efficiencies in thermal energy systems, so in your day-to-day operational practices. So what are some of the thermal energy best practices, and what are some new low carbon technologies, low carbon or even zero carbon technologies that we can look into? I saw mentions of heat pumps and other interesting opportunities being suggested in the Mentimeter survey. So these are the things that we will be considering in the next 20 minutes that we have. Yeah. Next slide. So energy management information system, in short, EMIS. So EMIS provides a greater transparency of organizational energy performance to all levels of the organization in real time. It allows a tiering of the visualization of energy consumption in all hierarchical levels. Let's say if you look into a plant, the top management doesn't want to be concerned with individual equipment energy performance. The top management just wants to see overall energy consumption trends, overall SEC of the complex, and overall energy cost of the complex and how it is varying over time. When you look at plant managers, the next level or below the top management, they are concerned about energy balance, mass balance, plant level specific energy consumption of significant energy consumers, and so that they are able to pin down respective production managers or operators where things are not going in line with the typical trend. So that's when you look at operations in the production team, what they have to see is specific equipment metrics, specific operational parameters, whether these parameters are kept within their limits, is there any operator action required. So essentially an EMIS not only provides real-time energy information, but it provides a tiered approach to energy information management. So in addition to that, it enables reporting, as you can see, and decision support. So when you know something is out of range, some operating parameters are not managed in the ideal way, it triggers operator behavior, and it creates an overall energy-driven culture within the organization. And so you can have open loop systems, which are just informing only, and there are closed loop systems, which in addition to informing, they also take actual action, to control energy consumption by the various equipments. So energy management system, information system typically comprises of comprehensive metering infrastructure to capture the data and visualization software to allow users to track data trends and energy performance metrics over time. We just discussed that. In some cases, energy management information systems, they can also be coupled with advanced analytics solutions, be it machine learning-based forecasting analytics, anomaly detection analytics, or even failure prediction of equipment. So when an energy performance parameter is out of range, that also means that the equipment's performance parameter is also out of range. So energy and equipment performance could also go hand in hand. So that could trigger potential equipment fault detection. When is the next maintenance schedule to be triggered? So that the maintenance team can also get a better understanding of the mean time to failure, and so that they can schedule their repair time accordingly. So it also helps schedule maintenance as well. Some of the parametrics, performance metrics that energy management information systems tracks: the energy balance, team balance, equipment level efficiencies, and specific operating parameters. Okay, move on to the next slide. Next slide. Yeah. So metering the total plant energy is good, but it doesn't show how energy consumption is distributed across the various areas. It's like telling you, your car mileage is 12 kilometer per liter, but doesn't tell you how to improve that mileage. How much does air pressure of your tires affect your mileage? How much does the engine performance affect your mileage? You don't know. So you just know overall figure that good to know, but it doesn't tell you more information that you can actually act upon. So that's why sub-metering is very critical, because it allows a measurement of selected areas of energy use and gives better understanding of where energy is used and where there is scope for energy saving potential. And some sub-metering strategy to be considered: sub-metering by area, floor, zone, building tenancy, or by departments, or plant areas of operation, or by energy systems. There are significant energy users that consume up to 80% of the energy consumption in the plant. It's sometimes good enough to actually have sub-metering around these significant energy users. The 80-20 rule, right? You don't need to measure every small motor and drive. Maybe the significant energy users could be considered first for sub-metering. Next slide. So now we are moving on to the next, recommendation is basically looking at operational efficiencies of key thermal energy systems. We'll be talking about boilers, furnaces, and I think we'll be talking about ovens as well. So typically, in a food and beverage industry, these are the key thermal energy consuming systems. So if you look at these pointers in the boiler, they are all action words: inspect, match, ensure, inspect, investigate. So they are actually best practices or ideal considerations an operational routine should have. So for instance, it's definitely important to inspect and maintain boilers. A poorly maintained boiler can consume 10% more energy than the one that has been well maintained. So it's very critical to match boiler outputs to process load or site requirements. That thus ensuring optimal loading of the boilers, especially if you have multiple boilers. And ensure effective insulation. We have always stressed the importance of this. This is heat just thrown into the atmosphere, right? An appropriate functioning of steam traps through regular inspection. We have conducted a comprehensive session to share steam trap management and steam system management best practices. So typically in a plant, 10% of the heat could be produced in a boiler could be lost through inefficient or insufficient insulation in the distribution system. Continuous inspection of water quality. While manual TDS control is the cheapest way to achieve TDS control, but it tends to be laborious in nature, and it can often lead to excessive thermal loss, especially when you have frequent blowdowns. So an ideal solution to this would be to have automatic TDS control. This prevents foaming, carryover, boiler water, corrosion of steam and condensate system, while also helping to save boiler fuel. For a rule of thumb is that for every 1% reduction in boiler blowdown, you save about 0.2% of fuel. It's a very, very low hanging fruit. Another thing is to investigate the potential for recovering waste heat. That's a very critical thing to have. Investigate installing automatic controls and use isolation procedures for boilers. Replace boilers that are close to the end of life. That goes without saying. Sometimes you tend to operate with boilers that are beyond their life, and that's when they start to give mechanical issues, maintenance-related issues, and then it can be more expensive to also maintain them beyond their life. Next slide. So as with boilers, furnaces, ovens, or any energy, thermal energy systems, I would like to stress that there are three main aspects of consideration for efficiency, not something we don't know. It's basically heat generation, heat containment, and heat transfer. How efficiently are you generating thermal energy? How effectively you're containing this energy, minimizing loss to the environment, and how effectively this energy is transferred to your heating load. So if we can ensure that all these three aspects are sealed, that's when you're driving maximum efficiency in your thermal energy management system. So the holy trinity: generation, containment, and heat transfer. Improved furnace insulation is associated with retention of heat. Improved refractory materials for effective insulation against heat loss from the outer walls of furnaces. For sizable furnace, this is actually as simple as a visual inspection, because when refractory materials are worn out or becoming poor, not doing their job, leads to development of hot spots, and this can actually be visually observed in the form of discoloration on the exterior walls of furnaces. So especially when you have box type furnaces or reformer furnaces, this discoloration is very obvious, and that's when you need to either consider replacing the refractory material in the next shutdown to prevent further hotspots or deterioration, in addition to, of course, heat loss from the furnace walls. So improved furnace control strategy. So if one were to take a typical furnace loads and the associated energy use, invariably there is a lot of scatter in many of the plants. This shows that they are independently distributed. This should not be the case because the furnace load should be closely associated, correlated with the energy use. The furnace uses different amounts of energy, normally the same production load. That's why it leads to this scatter in terms of furnace load versus energy use. So a typical example, in many of the plants they use is a feed-forward control scheme. Any load change in the feed minimizes the coil outlet temperature for the furnace. In this way, you regulate the energy used by the furnace with the varying loads. Of course, another control should be to control the air-fuel ratio to ensure complete combustion. This is something that we all are very familiar with. Too much excess air leads to low flame temperature. In order to heat up this excess air, great volume of air, the combustion chamber needs to burn more fuel to achieve the required heat. And of course, incomplete combustion, on the other hand, leads to loss of unburned fuel in the flue gas. So either way, you tend to lose fuel. So it's very important to establish a strong control over your air to fuel ratio. Sealed burners, conventional under-fired gas burners tend to inspirate cold air. A simple sealing ring can eliminate ingress of cold air into the furnace, thereby increasing the efficiency. Also, one thing to note here is that all peepholes and header boxes must also be tightened to eliminate air ingress. That could also lead to heat loss. Another option that, sorry, I think, Luis, there's a change in the screen. So yeah, now we know how busy Luis is. Yeah. So another option is to also consider the stack damper. Stack damper is something that tends to be also ignored. It should be frequently inspected at every shutdown, necessary modifications made as needed. While many plants tend to have manually operated stack dampers, what tends to happen in the operators is that they try to leave it fully open most of the times to prevent potential tripping of the heater. And this leads to ingress of cold air and also loss of hot flue gas. So there is a need to actually control the dampers. So preferably with smart stack dampers, either with 2-blade or even 4-blade dampers nowadays. You have 4-blade dampers to have better control over the draft in the furniture, in the furnace. Sorry. Next slide. Ovens. In ovens, improving some of the typical operational efficiency enhancement practices include improving combustion or efficiency of ovens using radiant burners with improved control over oxygen levels, excess air levels, O2 trimmers. So improved insulation. So if your oven is already old, you can also consider spray-on coatings, such as a Sinofex heat shield, specifically designed for thermal ovens. Or nowadays, there are also alkaline earth silicate fiber coatings for ovens. Improved control of oven cooler fans, either through VSDs for the fan motors or set point control for fan operation. Oven heat recovery, this is specifically for indirect ovens that use convection. So the flue gas can be, heat can be recovered from the flue gas using heat pipes or self-cleaning heat exchangers. Maybe a little bit more time about heat pipes. Heat pipes are contraptions that are used for heat transfer between two surfaces. So typically heat pipes are evacuated in sealed pipes. So they have a working fluid that is running within these pipes. And it's a two-phase operation that's going on within these pipes. To enable efficient transfer of heat between two locations. And self-cleaning heat exchangers are typically heat exchangers that have on the fouling side a fluidized bed of solid particles that allow scrubbing of the fouling side, to remove any scale or any effects of fouling. So thereby preventing hotspots from developing and allowing for efficient transfer of heat, and also protecting these equipment from mechanical failure due to overheating over time. Right? So of course, you can also explore alternative heat sources such as microturbines or hydrogen from fuel gas to provide the hot gas required for ovens. Next slide. So we've seen what are the to-dos in operational aspects for thermal energy systems. Now, what we have outlined here are typical thermal energy best practices in the food and beverage industry. We have around, I think, 4 or 5 items here. And you might observe that they are largely centered around boilers, because every plant, a food and beverage plant has a boiler. And boiler is a central thermal energy generator in all the plants. It's a common factor. So we decided to spend more time on thermal energy best practices in boilers. You might also realize that some of these pointers have been discussed above in the boilers already. But here we just put in more numbers in terms of potential savings, payback period, and so on. So the first one is modulating burners. That have exhaust control, exhaust trim control, and also controls flow of fuel with regards to the coil outlet temperature, with regards to the heat load that is required. So these modulating burners help to reduce fuel consumption by 10 to 15%. And payback period could be realized in around 2 years. So another aspect is also feed water modulation control compared to using on-off boiler feed water pumps for feed water addition. So typically for boilers, the feed water pump is oversized, especially to meet with the sudden demand for boiler feed water should the boiler calls for it. So when this happens, the pump literally overloads the boiler steam drum with much cooler water, and this results in a surging quench. Right, and this causes the boiler steam drum pressure to drop significantly, and that's when the firing control is triggered to send in more fuel, to burn more fuel, and this results in a wasteful cycling process that unnecessarily consumes more fuel for the same heat that is eventually accomplished. So with modulation control, you can expect a smooth operation with constant, especially in operations where you need constant cycling of fuel consumption. So this reduction in the short cycling of the boiler operation can lead to fuel savings in the range of about 5%, and typical paybacks is less than 3 years. And next slide. So we already talked about automatic TDS control. I won't spend more time on this. So another option below is using economizers to preheat boiler feed water. That's also something that we already saw. Fuel savings in the range of 4 to 6%. And if you're using also for preheating the combustion air, to reheat combustion air using the flue gas, you can also realize more energy savings. But the catch is that it depends on the sulfur content in the fuel, how much heat you can recover from the stack. Because if you go down too low, then you would risk acid dew point. So, but typically gas as a fuel, gas-fired boilers, you can actually go down to 120, 130 degrees Celsius safely. Yeah, giving you a safe room, before acid dew point is reached. Next slide. So one other option is also to use plate heat exchangers to heat up the coal boiler makeup water, either by using blowdown water or if there is any surplus vented steam in the plant to increase the boiler efficiency. Especially if you have existing plate heat exchangers within the plant, they can be retrofitted, or piping can be rerouted to use them for preheating makeup water. And condensate recovery systems that allow for recovery of at least 85% of the condensate as a best practice to the boiler feed water tank is critical, not just for fuel economy, but also for water economy, and also for saving chemicals that are added. So rule of thumb is that every 6 degrees increase in the boiler feed water temperature achieved from condensate return, or if you achieve boiler feed water increase by economizers also, it will deliver a 1% increase in the boiler system efficiency. And simple payback is actually quite short, in a matter of a year or two. Next slide. So we can't stress the importance of this. So insulation is also key. So all hot surfaces needs to be properly insulated, and constant steam surveys needs regular steam surveys. Constant is too much. Regular steam surveys need to be conducted to ensure that surface temperatures of insulated surfaces are not more than 40 degrees. This is not only energy saving procedure, but also a safety aspect, because especially for boilers, when you have boiler operators working around the systems, especially for operators moving around the steam networks, it's also very important to ensure that there are not any venting steam or insulation that is poorly functioning, such that there are hotspots developing on the steam network, beyond 40 degrees. So that's also a safety hazard. So it's killing two birds in one stone. So as much as we have safety culture in a plant, it's also critical to have energy culture. Yeah. Next slide. So we have so far seen operational practices. We have seen best practices in energy management, thermal energy management. And the last segment that we will be covering on in terms of technical aspects of thermal energy management is low carbon technologies. So regulatory pressure, and in some countries, incentive landscape as well, along with environmental concerns and increasing fuel costs and increasing uncertainty around fuel costs, are driving more companies to adopt and integrate low and zero carbon energy technologies into their facilities. So we will, and of course, the list is inexhaustive. We will just cover like around probably 2 to 3 of these technologies in the next upcoming slides. So, there is no point talking about typical energy saving technologies, because people like you are already in the industry, very familiar with what is out there. So we talked about some things that are less talked about. So things like solar thermal. Solar thermal systems basically use solar energy to channel it to heating water, so they can be used to offset the load of hot water boilers, or in some cases even replace hot water boilers. So there are 2 different types of thermal energy collectors. So flat plate collectors are ready to implement low cost, low maintenance systems. So they are, however, the catch is that they are only suitable for heating water in the range of about 30 to 80 degrees Celsius. I mean, if that is the range of hot water temperature that you're looking at, this is a readily available solution that is also simple to implement and operate. And the maintenance aspect is also very negligible. So the thermal efficiency of the flat plate collectors is typically around 70%. But yeah, solar energy is free, right? Evacuated two collectors. So these are slightly more complex equipment in terms of, these tubes need to be evacuated and backfilled with working fluid, same as the heat pipes that we saw earlier, right? They are, however, although they are slightly more cost intensive, they offer the advantage of being used for a wider range of temperature operations, from 50 to all the way to 150 degrees Celsius. And their thermal efficiency is around 80% effectiveness. Yeah. So we move on to the next slide. Yeah, low carbon technologies should always talk about possible electrification of thermal energy. We saw earlier that thermal energy is going to be 70 to 80% of a plant's energy consumption in the food and beverage sector. We can't change that. We want our cornflakes to be toasted. We want our pastries to be puffed. We can't do anything about that. We still need thermal energy. But what we can do is to potentially electrify this thermal energy. So electric boilers, these are your typical water heaters at your home. So that's that they are in an industrial scale. So one thing to note is that electrification of heating application, enables a plant to offset the emissions associated with thermal energy by procuring renewable energy or through rooftop solar. Of course, if you're going to use electricity from the grid, there is still a carbon factor associated with the grid. And you are still going to have a scope 2 footprint. So in order to offset it, there's a need to either buy renewable energy or outfit rooftops with solar. Yeah, electric boilers tend to be more efficient than gas-fired boilers, and they allow better control over steam generation. And they tend to be easier and cheaper to maintain. And so it's nothing beyond your minimal routine inspections is required. But of course, as with any other boiler, they do require scale control measures. You do require periodic blowdowns to maintain your efficiency, prevent accumulation of TDS. And of course, when there's a need to replace heating elements because of failure, it's always a simple process, and it can be easily accomplished with a boiler door. You can see here. So when our electric boilers economical, when the central boiler turn downs are high, the low load operations can be met with electric boiler, or when your plant is in shutdown, or when you have other typical low load operations, instead of operating boilers at high turn down, you can consider using electric boilers dealing with the steam required. When you have applications that require quick startup, high cycling, electric boilers are also ideal economical considerations. Next slide. Heat pumps. So we did mention heat pumps in one of the surveys in the Mentimeter. So heat pumps are typically electrically driven. So they actually help to transfer heat from a low temperature environment. So low temperature means low quality heat source, such as your ambient air, low grade heat, water, maybe condensate water, or other waste heat that you can recover, and raise it to a high quality, higher temperature heat for useful applications. So this is made possible through a typical refrigeration cycle. You can see on your right hand side. So heat pump efficiencies are typically mentioned in the form of coefficient of performance, just like the chillers. So the ratio of heat delivered by the heat pump is in the numerator, divided by the amount of electricity required to drive that heat or generate that heat from the heat pump. So heat pumps can be integrated with existing systems and services to operate in series or in parallel to totally replace or provide part of the thermal load. Specifically, when you want to generate hot water, so your hot water boiler can be offset with the use of heat pumps. So some of the potential waste heat streams you could consider for upgrading to heat pumps are heat rejected from chillers, refrigeration systems, or dryers, or other wastewater streams. Even in your wastewater treatment plants, if you have heat, then that can also be recovered using a heat pump and delivered to a higher quality temperature heat requirement. Yeah, I think that's the end of the slides. We can move to the next slide. Is that the end of mine?
Yes, yeah, thank you,
Yeah.
Karthik. Kalyani, I'm just going to hand over to you now for the next section.
Thanks, Eloise. Do you mind if I screen share?
Absolutely.
So I've just dropped a link to a website where we can run you through self-assessing your steam system in your factory. So I will just walk through how to get there, and let me just share my screen now. Okay, so hopefully you can see the website that I shared on the chat box. So if you just scroll down all the way to this energy management self-assessment tool, and then you can click on something called the top 10 energy efficiency technology tool, and it will just download an Excel sheet that you could just have a play around, and I'll talk you through how to use this to do a bit of a self-assessment on where your facility stands with regard to steam systems. So I'll just give you a moment to open the Excel sheet. Okay, and then once you have it open, if you could go to the Steam tab over here. So this tool covers a range of different technologies that are relevant to the food and beverage sector. But since this workshop is about thermal energy, we can just look at steam for now. And what it allows you to do is respond to whether or not your factory is in alignment with different best practice criteria, and then gives you a bit of real-time feedback as to what to do if you're not quite aligned yet, and any next steps. So all you need to do is start by entering your company name. So I'll just enter Carbon Trust for now. And then you just select the fuel type that you are using for your steam system. And then you choose the currency that you use to purchase that fuel. And then your factory's total fuel expenditure for that particular fuel that you have selected. I'll just put a dummy number here, and then this this part is just for you to enter what percentage of your site uses steam systems. So it's just an estimation, and it will help to make the answers later on more relevant in terms of payback period or the cost savings that you can achieve. So then I'll just talk you through question 1, and then maybe give you a few minutes just to play around yourself and see how the tool works. So the first question is about, do burners operate with trim control to keep excess oxygen levels less than 3% across firing range? So you just need to click this arrow and say yes or no. So in this case, I will say no. And then you get some immediate feedback. So in this case, you can see that it's telling us that because we're not aligned, we should consider applying this best practice, because retrofitting modern modulating burners with exhaust gas trim control typically reduces fuel consumption by 10 to 15% and burner electricity consumption by more than 30%. So in this case, it could save our company about 7,500 ringgit annually, reduce our emissions by 11 tons annually, and you have the simple payback calculated as less than 2 years. And then you have a bit of next steps. So here it's really telling us that if you don't act on this, then the cost of inaction is really 21 ringgit every day in wasted fuel. So I'll just give you a moment to play around with this. And if you have any questions while you're engaging with this tool, just drop any thoughts, feedback, or questions in the chat box, and we can address them towards the end. And I should mention that our knowledge partner is Sarco, so they're an expert in STEAM solutions. So if there's any area where you find that, oh, you're not meeting best practice, then that's someone we could connect you with, as they do have a presence in Malaysia.
Yeah, absolutely. And I think something that you can use this tool with, you can take this tool away, download it, play with it. And what it can act as is potentially a reference point for justifying some action on any of these activities. And, you know, hopefully the CO2 equivalent tonnage and the financial, the rough financial rough financial figures will be enough for you to kind of put this to decision makers or help make those decisions yourself on where to prioritize activities and how that's going to affect your carbon footprint as a business. Kalyani, shall I take back control of the screen?
Yes, let me unshare.
Are there any questions in the short term for Kalyani on the tool? Great. Well, fantastic. Kalyani, you can see my screen again?
Yes.
Fantastic. Well, moving on to the next section. Hopefully you found that useful, and Kalyani, we will share the link again after this workshop, so you can have the link to the website, and there are other tools in there which we'll be running through in due course. Here's the information here. So now we're going to hand over to Desmond He, who's representing Petaling Jaya Dairy, to talk through his and his organisation's experience in managing thermal energy and how they have been saving thermal energy on their plant. Desmond, I will hand over to you.
Okay. Good afternoon, everyone. My name is Desmond He. I come from Petaling Jaya Dairy, Malaysia. So today is a great honor for me to share some experience, challenges, and why are we in the journey in terms of a thermal energy saving roadmap. So in these slides, you see the roadmap that I have put it to 3 phases: beginner phase, intermediate phase, and advanced phase. So in the beginner phase, we stress on visualizations, which understand your plant steam usage, install steam flow meters, mechanism of data monitoring. So in next slide, I will further elaborate what is the visualization. Next slide, please. Yeah, okay, thanks. Steam consumption visualization. Install steam flow meter, usually is Voltex flow meter, come with totalizer at strategic locations, especially for big consumers, and start steam data collection. Every plant is unique, yeah. So we need to know our plant, our processes, and our steam requirements. To understand our plants and processes is important because by understanding our plant well, we will be able to identify opportunities and limitations with the steam data collected. And this information is also essential for us to strategize our execution and improvement plans effectively. For example, some plants will run during weekdays and stop in weekends. Some plants, some processes will run for a month and stop for only a month once. And some plants may stop 6 monthly once. And some plants may not stop and they will run throughout 365 days. We have to understand our pattern of running and see how can we deploy our plans. So for older plants which have had modifications, we review steam pipes if they are correctly sized in steam distribution systems in terms of mass balance. because sometimes after modifications, maybe somewhere it's wrongly sized. Then we have to review and correct them. So based on historical data collected, we also can do benchmarking. So this is the preparation for the next phase. And a mechanism for data monitoring is important in order to visualize pre and post results of each improvement projects to quantify our savings. So with this in place, then we can move on to the next phase. So this is how Petaling Jaya Dairy Malaysia has been moving. Next slide, please. Yeah, so come back to energy thermal saving roadmap. So in the intermediate phase, we are doing foundation building. So Petaling Jaya Dairy Malaysia is focusing on foundation building. We are now building in order to gear towards sustainable model, or we call mastery, yeah, model. So what we build up with project banks and also purchase useful measurement tools for routine inspection. So moving to next slide, please. Next slide. Yeah. So for thermal energy foundation building, what we have done is we established steam traps management program. From the table below, you can see we conduct steam traps assessment yearly. And if we found any steam traps which are not working, we will replace them and restore back to basic condition. When we assess our boiler efficiency, we also establish routine steam leakage inspection walk in plant regularly. So this is important, and how we do it is we set KPI to our subordinates and let them start working on the habits. So going back to what I have said earlier, every plant has its own characteristics and patterns. So if the plant is not running in weekends, for example, then the staff can have a walk in the plant, because if all the machines are not running, we can hear and we can see easily leakages, not only steam leakages, but also water, compressed air, and idling running machine if there is any. So all these leakages should be addressed using these routine jobs. So heat recovery, we are doing return steam condensate, first stage economizer, condensing economizer, also better known as second stage economizer, blow down flash tank. So these are the few technologies which we are doing, we are working, and we are using. So for the first stage economizer, from the picture below, an economizer is a heat exchanger that recovers heat from flue gas and preheat the boiler feed water. So the advantages is to increase the boiler efficiency, decrease stack temperature, yeah, and also improve the overall performance. Next slide, please. Okay, so Petaling Jaya Dairy Malaysia is building the foundation to gear towards sustainable model. So in sustainable and mastery model, that there should be annual financial cycle of budget or capex allocation on thermal energy improvement projects and thermal energy tracking. This is why we need to have the mechanism of data monitoring. Once we have a system in place, and with every project implemented, it should be reflected. It should be reflected on the data collection. So with that, we will be able to assess how well we have get it executed and what is the impact. And also from there, we know how to move forward. So review process and improve for energy efficiency. Yeah. So to improve the optimizations. So this also is always doing, and also conduct steam utilization assessment. This is also important. So in the advanced state. Next slide, please. Okay, so for Petaling Jaya Dairy, we are executing energy savings, but at the same time, we also having challenges. So what are our challenges? Basically, Petaling Jaya Dairy is an old plant with more than 50-year-old. So aging pipes is one of the issues. And by routine leakage inspection and replacing them, we are trying to restore back and try to prevent any heat loss here. Yeah, but then second is the aging equipment. Some of our old economizers also we are planning to replace because it may leak after more than 10 years operations. The third, the heat surface, which is a high temperature with worn insulation. We are also trying to address with the hotspot found with the thermal imaging. So we are replacing the insulations. Okay, next slide, please. Okay, so why are we in the journey of this thermal energy saving? So we can play our role better to give a better earth for our next generation. So it's for our children. So by monitoring the gigajoule and the ton CO2 equivalent, which is the CO2 emission, we can act on it and improve it. So let's together help our Mother Earth with electricity, thermal energy, and water saving journey. So it's never too late. So with the appropriate actions and together, we can reduce extreme weather and we can give better fresh air, conserve energy by recycling energy, reduce unnecessary waste as well. So together we can build a better future for our next generation. Last but not least, I would like to thank UK Carbon Trust and UK government for the opportunity to participate in this LCEP Thermal Energy Audit Program. With this, I would like to end my presentation. Thank you.
Thank you very much, Desmond. That was incredibly interesting just to see from a perspective of a Malaysian organization on the front line, working on this as a site issue every day, and get that perspective of how Petaling Dairies is moving forward on their energy management and thermal energy management journey. So thank you again for contributing. We're now moving on to the next section of the presentation of the workshop, which is going to be led again by Kalyani, who's going to be looking a bit more about how you set up an energy management system to manage your energy on your site. So Kalyani, handing over to you.
Thanks, Eloise. Next slide, please. So many organizations would like to save energy, but they need to make energy management an integral part of running the organization to really ensure success. So a management system is really a set of policies, processes, procedures that an organization needs to follow in order to meet its objectives. In some small organizations, the management system might not need to be formally documented, but in the more large organizations, it's more likely that processes do need to be documented to ensure greater clarity on how they're conducted and by whom. So all management systems follow this plan, do, check, act, which is a continual improvement framework. So plan here means just establishing what needs to be achieved and organizing the resources around this. And then do relates to actually implementing those processes that have been established. Check is around monitoring and measuring the processes and their outputs. And finally, act is really responding to the findings from all of the checking activities and guiding the path to improvement. Next slide, please. So the key elements for delivering successful energy management is illustrated in this roadmap here. I will go through each in a bit more detail in the next few slides, but as an overview, the first step to conduct or set up an energy management system is doing an initial review to really get things going. And this will involve understanding your organization's energy use, cost, as well as legal obligations. Then the next step is getting senior management commitment. This is really the foundation of good energy management and must be secured first. Once that's done, then the crux of the energy management system is really delivered through an energy policy that is formalized, and then supporting energy strategies with an action plan. Finally, it's necessary to formalize energy management and integrate it throughout the system. Next slide, please. So in order to implement an energy management system, an organization needs to understand both itself and the internal and external issues that affect it. So this understanding then needs to be used in the implementation of the system. So in this step, it's important to go through the good and the bad practices. So you should question whether your energy management is currently set up in a structured way, and whether it's viewed as a strategic issue. You should question whether your energy management is adequately resourced with the right people working on it, and it should not be viewed simply as an overhead. Energy management should be well integrated into how it defines your monitoring system. So it should go beyond financial monitoring to pursue energy reduction measures. And then you should assess whether your current procurement policies include energy, and if it's proactively reviewed. And then at a broader organization level, it's really important to consider whether thinking around energy use is something that all employees are aware of and actively practice. And then lastly, energy management should really be seen as an opportunity across the organization. Next slide. So once your baseline is established through that initial review, the areas to strengthen energy management must then be communicated to senior management. And this is to ensure that the energy management system is provided with the support and the resources that it needs to achieve its aims. This will ensure that energy-related matters are being taken into account in high-level decision-making, and that it is actively discussed across departments and employees. Next slide. Now, the energy policy is what defines the strategic direction of the organization with regard to energy, and should be seen as an element of the overall business strategy of the organization. So this energy policy statement should set out very clear objectives as to what the organization's current goals are regarding carbon and energy. And it should incorporate wider business goals as well. The statement should be quite objective driven. So if there is an intention to go beyond standard legal requirements in your country, then this should be specifically stated out in your energy policy. And this is really the time to put as many quantitative targets as you can within this policy. And then there should be some wording around how you plan to integrate energy management across all organization-wide decision-making. So this includes how you plan to commit resourcing to energy management, how you plan to develop trainings related to energy management for your staff, and how energy management should be integrated within your formal review process and the frequency of this. Next slide. So here you can see what a sample energy policy looks like. So in this case, the company has highlighted their goals in terms of short, medium, and long term. So in the long term, some of the things that this company has put in are related to reducing energy costs, prioritizing energy efficiency investments, considering the life cycle energy costs for new projects, minimizing carbon dioxide emissions. So you can see that the long term, it's much broader, more strategic levels of objectives that are set out. And then in the short term, the objectives are more tangible, more quantifiable and concrete. So here in this example, the company sets out that they plan to quantify their reduced emissions and energy consumption. So they have the allocated percentages of reduction. They're also committing to achieve accreditation. They're setting and publishing performance improvement targets. They plan to establish a monitoring and targeting system and even establish a budget specifically for investing in energy efficiency. So you can see that there is a clear expression of the organization's energy and carbon vision with very specific objectives. So ultimately, the energy policy should be short and succinct and be signed by the chief executive or an equivalent party and be a public document. Next slide. So now a policy on its own will not really deliver energy savings. So while the policy provides the mandate to develop an effective energy management system, a working strategy is needed to deliver that policy. So the energy strategy should really be developed by a team that has the ability to secure organization level buy-in. It should take into account the resource availability and needs and appropriately assign responsibility. It should definitely include a procurement strategy, and it should include a plan to manage energy information and sufficiently allocate reporting duties. And lastly, it should be formal. It should be adopted by senior management, regularly reviewed, and be time specific. Next slide. So within this strategy, I talked about allocating key responsibilities. So this slide covers some of these responsibilities, and really whatever the organization's starting position is, the strategy should definitely include an assignment of energy roles that have sufficient responsibilities allocated. So these should include someone who is in charge of monitoring and managing energy use and developing benchmarks, someone who is able to identify and implement energy management opportunities, a party that is looking at inputting the strategy into maintenance, purchasing, or new build decisions, and then someone or a team who's responsible for communicating the energy strategy to the organization. And there should be an energy manager in place to oversee these activities and even take on some of these responsibilities. Next slide. Now, another aspect of setting the strategy is considering investment. So energy efficiency investments often have to compete directly against other demands for capital budgets. It's likely that capital budgets will need to be specifically allocated to energy efficiency for the organization in order to enable it to meet its energy policy objectives. So good investment practice can be characterized by having a ring-fenced budget for energy efficiency that is under the control of the energy manager. So this avoids the danger of funds being diverted away from energy efficiency. Secondly, there should be retention of at least a proportion of energy savings by the function or department to which they relate. So this provides that incentive or reward for pursuing energy efficiency. Thirdly, there should be retention of at least a proportion of energy savings for investments in further sustainable energy measures. And lastly, there should be an appraisal on a whole life cycle basis when comparing energy efficiency investments with competing demands on capital funding. Next slide, please. So I'll just go a bit deeper into the concept of life cycle costing. And this is really about getting that full picture of how much equipment will cost over its life. So in this case, it's an example of the purchase and lifetime energy costs for two similar refrigerated display cabinets. So here you have cabinet A that has a purchase cost of $6,800. And this is $1,100 more than the cost of a very similar cabinet B. In terms of energy consumption, cabinet A consumes 44 kilowatt hours per day, while cabinet B consumes 55 kilowatt hours. So if you assume that the cabinets have a life cycle of 10 years, then within this period, you can see that cabinet B has energy costs of over $3,500 more than that of cabinet A. So what this means is that the lifetime energy savings that are achieved by choosing that more efficient option will actually repay that price premium in the purchase cost for cabinet A more than 3 times over. Next slide, please. So another aspect of the energy strategy is procurement. There are two areas of procurement that are critical to an effective energy management strategy. One is the procurement of energy itself, and the other is procurement of energy using equipment and services. So energy procurement is really about getting the best price for the supply of energy. Effective procurement of energy may not save energy or carbon, but it can reduce energy bills. So without that knowledge of how and when your organization uses energy, you could be approaching the market at a disadvantage. And oftentimes it's the finance department that's responsible for buying energy, but not for managing it. So it's quite important that the split of roles is clear. So you can make smart decisions about energy procurement if you have that understanding of the markets and you know how your organization uses energy. And then with the procurement of equipment and services, it's best practice to have procedures in place that ensure the energy performance of such items are being taken into account. So procurement policies should ensure that service provision agreements incorporate energy efficiency related terms and conditions and should reference particular performance standards. Under the procurement policy, the energy manager should have a formal role in the decision-making process for service contracts and have that ability to sign off to ensure that procurement is consistent with the objectives of the organization's energy policy. Next slide, please. Now, effective energy management requires formal systems to be in place for data collection and analysis. So metering and monitoring systems are there to give the energy manager that timely and relevant information on energy use. They're there to provide the ability to investigate energy performance further and take action to rectify performance issues. They're also able to provide energy reports to support accountability for energy use and that ability to verify energy savings following the implementation of new projects. And the senior management team should also receive regular reports that are generated by the system in order to assess the progress with implementing the energy strategy and seeing whether what's happening is meeting policy objectives that they had signed off on. Next slide. And then the strategy should also include ways of identifying energy savings opportunities. So this can be done through the analysis of energy data that was generated through your metering and monitoring system, as well as through energy surveys. So there are 4 types of energy waste that one should be looking out for. One is just unnecessary waste. So things like the equipment and lighting being in place that's really not necessary. This is something you should watch out for. The second category is poorly controlled. So any systems, timers, temperature controls that are wrongly set, there is a good opportunity to reduce wastage in this area. Another type of wastage is just the result of inefficiencies. So this could include poorly maintained boilers, the use of standard lamps instead of energy savings ones. And then the last category of energy waste is just simply inappropriate processes. So in this case, the use of inappropriate fuels could result in a great deal of wastage. Next slide. So at the end of developing this energy strategy, communication is key. It's really important to communicate the energy management plan to employees at every stage, as effective energy management relies on everyone being involved. Energy management recommendations could be publicized via an energy action plan. So an example of this is here, where you can see that the recommendations are accompanied by their respective energy, emissions, and cost savings, as well as the capital investment requirements, as well as the payback period. So in addition to presenting all of this, it's also quite useful to have a suitable timeline for taking action, as well as what are the next steps. So all of this will make your policy much more strategic and actionable by the organization. Yeah, I think that sums up the energy management section. So we now have another short tool that I will just walk through with you. Eloise, do you mind if I show? All right. So if you go back to the same link on the accelerator and scroll down to the energy management self-assessment tools, you will see here under the energy management assessment tool, there is an Excel sheet available for download. So please to download that now, and I'll just do a short walkthrough on how you're able to assess your current energy management system and identify room for improvement. So in this tool, you'll see there are 3 tabs. Tool 1 is the one I'll walk you through right now. Tool 2 is a bit more comprehensive and is something that you can take away following this workshop. This one just allows you to go deeper into all of the aspects that I talked through just now. And the output of tool 2 gives you a deep dive visualization of how you rate against different criteria for a robust energy management system. But for now, I will just go through tool 1. The purpose of this is to give you a quick and easy assessment of how you stand and quickly be able to present to senior management about areas where you could improve upon. So here you have some of the key criteria that's necessary for an energy management system. And then you have the different levels of best practice for each category. And all you would need to do here is just score where your company currently aligns most closely with the description that's presented against the score. So I can just talk through one aspect, so perhaps the energy policy. So here it starts out, if you score 0, it means that you don't have an energy policy as yet. If you do have a set of guidelines, but these are currently unwritten, currently not formalized, then you can rate yourself as 1. If you do have a policy, but it's not really adopted by your organization, then you can rate yourself as 2. And then 3 is more about if you have that policy in place, but there is no active commitment from senior management, you haven't been able to get their buy-in, then you can rate yourself as 3. And then 4 is just best practice, where you have that energy policy in place, you have that action plan, there are regular reviews going on, and you have strong and active commitment from top management. So I can just rate myself here, let's give myself a 2, and then immediately the color comes up. So it's a really good tool to visualize where you stand, where your strengths and weaknesses are, and you can just present this to your team as a way to say, these are the areas where we're doing well at, and these are the areas that we could improve upon. So yeah, maybe after this workshop, you can take some time to play around and definitely try tool 2 when you have a chance as well. Over to you, Eloise.
Thank you, Kalyani. I'll just reshare my screen. And give us a nod if it's all worked perfectly. Fantastic. Great. So again, thank you, Kalyani, for that. That's, again, something quantitative, something tangible that you're able to share with your teams and your colleagues and also your senior management for decision makers, and hopefully gives you something tangible to share with them and guides you on how you can address some of the weaknesses within your organization around energy management. Now I'm handing over to one of our partners on the ASEAN Low Carbon Energy Programme, Cofreth, and they were going to talk to you about a project that we're currently doing on thermal energy in Malaysia, which I mentioned briefly at the beginning of the workshop, but I will hand over to Cofreth now, who will talk you through in more detail. Thank you, Chin.
Hi. Thank you, Leonis. I'm Chin. I'm from Cofreth, local partners of Carbon Trust in Malaysia. So I would like to talk about the inductions of thermal energy audit, energy study in Malaysia. I'll go to the next slide. Is our right. I think some background of the thermal energy audit. Thermal energy studies for Malaysia. So this we like to utilize the UK Foreign and Commonwealth Office and Property Fund as a carbon trust cooperating with Malaysian Ministry of Energy and the Energy Commission, the Suruhanjaya Tenaga, to implement the ASEAN Low Carbon Energy Program for Malaysia. So the objective of LCEP is to harness the benefit for deployment the LCEP by leveraging the UK extensive experience and expertise in energy efficiency and green finance. And take note that this LCEP I think will end in March 2022. And 5 countries has been selected to participate in this LCEP that are firstly Malaysia, Thailand, Philippines, Myanmar, and right now as okay. Then the 5 main objective of this program is to strengthen the policy and regulatory framework for the EE and green finance. You may ask, Malaysia didn't have the policies for EE? Yes, we have, but it is only for electrical energy, not thermal. B is to facilitate greater investment in low carbon technology. C, and to encourage fast reductions of greenhouse gases, which is the CO2 emissions, and increase in innovation and knowledge transfer on EE and low carbon technology. And 5, to increase likelihood of meeting our Malaysia and to the UN, the Paris Agreement on the COP21 for the climate targets, CO2 reductions. Next slide, please. Next slide. Okay, so why thermal energy audit thermal energy study? Sorry.
Apologies, bear with me 1 second.
Yep, sure.
The slide just dropped off my screen. Apologies, Jen.
Yeah.
Technical
No
difficulties.
problem.
Here we are. Here we go.
All right, back to the slide. Thank you. So why thermal energy studies? So in 2007, the National Energy Balance showed the consumptions of energy for both electricity and other fossil fuels by commercial factors has decouples from GDP growth. What you mean? This is by electricity increase or did not or decrease did not reflect in the GDP growth, and continuously increase on the thermal energy. These reductions of energy or energy efficiency for electricity is proven effective on our policy and legal and regulatory framework introduced by the government. For example, number first is the efficient management of electrical energy regulation, the EER, in 2008. I think in Malaysia, the industry is well known on this regulation. And number two is a minimum energy performance standard. Number three, the EPC, energy performance contracting, approved by cabinet, and so on. And on number four, the incentive for energy efficiency project. This energy is incentive only apply for electrical energy. And then number five is the reporting of the electricity consumption in the government ministry. And six is the UBBL also adopted the MS 1525, which is also tools to to have these electrical energy efficiency. So you can see that in Malaysia, there is no legal framework to promote energy efficiency in the thermal energy. So in the next future of year, the government have drafted the Energy Efficiency and Conservation Act, EECA bill, that will cover both electrical and thermal energy, and may be passed by government and parliament in the mid of 2021. But seeing the scenario in Malaysia now, maybe in the early of 2022. Next slide, please. Okay, so thermal energy constituted about 50% of total energy consumptions in the three building sectors, which is the residential, commercial, and industrial. You can see in the total subtitles, total of the thermal energy is a 12,000 KTOE, and the electricity also is a 12,000 KTOE, with 50% of the energy. And then why we only focus on the industrial sectors, and because industrial sectors is consumed 64% of the total industrial sector itself, the energy itself, 11,000 per 17,000 in total. Okay, next slide. Number 7, I think this one is mentioned by Karthik. The thermal energy consumption will continue increase in 20 years if the energy efficient program for thermal energy is not promoted. And this has been the case in Malaysia primarily due to the lack of actual and accurate data information among the 11 subsectors in the industrial sectors. Okay. Carbon emission of just three building sectors is 81,000 kiloton CO2, or 33% of total carbon emission of all sectors in 2007. And others carbon emission arise from electricity and thermal energy consumption is 49,000 and 31,000 kiloton CO2 respectively. And saving on energy consumption, not only the electricity consumption. So in thermal, if we save in thermal energy, focus on thermal energy saving measures, then we will have help in meeting the commitment we made in 2015 during the COP21 in Paris to reduce 45% of its CO2 intensity by 2030. Next slide, please. So, the benefit to the factories will participate in the in this carbon trust LCEP is the opportunity to receive free energy audit on heat generation equipment and heat use process, heighten the awareness on the level of EE of factory, introduce the best available technology of UK. You will be given a complimentary copy of the audit report, and contributing towards thermal energy benchmarking project of ST, which is we can have the local industrial data for the Energy Commission to establish the benchmarking. Then improve the energy efficient in your plant, then lower the operating costs and hence the financial saving, and also help to reduce the carbon emissions, contributing towards the environmental sustainability. And also it can be a CSR for the company, social and mankind, and finally the capacity building. Next slide, please. So the scope of study of our company in this LCEP project is to have the review of thermal energy use in Malaysia. So first we will have this prelim study on the data collections, the thermal energy generation equipment by the factories. We will collect all these energy heat use, fuel consumptions, and also the steam productions for the factories, as well as the heat use by individual process for the factories. So we target to conduct 25 energy audit in F&B factories over 1 year. So in the phase now, we are in this phase to conduct the energy audit. And next phase is to collect and analyze the data to determine the current barrier to adopt the energy efficient technology and measures. And next, we'll identify the energy saving opportunity for individual plants. Individual plants have a unique process of itself, so we will identify during the site visit, and then compute the financial impact and social impact of saving opportunity. And next, we'll produce the demand side management report, which summarize the findings and recommends the EE measures. So finally, for SD, we create this demand side management thermal energy plan to improve this thermal energy efficiency in Malaysia. So expected energy audit outcome will be, we would like to see the typical sector overview of thermal process flow of the factories and typical heat input requirements. What is their heat medium and temperature? And the heat efficiency metrics. What is their energy specific energy consumption? And number 4 is a best available technology. And finally, recommend this ESM for the factories. Next slide, please. So for example, for this first initial kickoff study, we will have requested from the factories to have this data collection for their historical heat use consumptions and also the heat generation, steam generation data. You can see here they have a monthly over the 2 years data with for monthly data and also analyzed data. But on this, only the heat use, energy use data, we cannot see the performance of the factories by generating the output of the production. So we request to reflect the SEC, we request is factories to furnish the production volume versus the energy use in the historical months. That will know the efficiency of the plant. Next slide. So after the prelim study on the test stop study, we conduct a field audit to the factories on the first the test stop study to study all these plant process equipment and as well as the plant situations and the site visit on the process plant. And finally, also we will visit the boiler plant to see the condition of the boiler. Slide. So in typical energy saving measure, I think previously Karthik already explained all these typical ESM for thermal use. For example, the preheating feedback water, feed water, and preheat the combustion air. And number 3, feed water treatment to soften the water. For heat recovery is the most important part among the all because the flue gas energy loss can typically up to 12% in the boiler heat process. So number 5 is installation of steam pipe, and number 6, monitoring the steam trap, avoid steam leakage, and also utilize steam at the lowest acceptable pressure for process. Next slide. As a non-typical energy saving measures, I think previously mentioned by Karthik also, is using the solar thermal system. In here, I want to explain one of the examples it can use to implement this solar thermal system in the AHU reheat hot water system. So in current the situations, the hot water to the air shield is heat up by the steam, and from the boiler supply steam, and the requirement only at 80 to 90 degrees C. So this and can easily compensate by the solar thermal system to as a hybrid system for this hot water tank to the air shield reheat system. Because solar thermal, the only limitation, two limitation for solar thermal, I think is the only work at daytime when the sun is up, and the temperature is ranged from 30 to 150 as mentioned previously. So this will offset some of the fuel consumption by the boiler. I think that's my last slide on this. Thank you very much.
Thank you so much for that. That's been excellent to hear a little bit about how we can, Carbon Trust can support companies and get involved in the thermal energy study. If you are, as an organization, are interested in having an audit, a free audit from Cofreth, please do reach out to Carbon Trust, reach out to myself or Kalyani, or even send me a message in the chat box today, and we will be able to get back to you. And it would be great to go to more food and beverage sites in Malaysia and support you in your and take an audit, do an energy audit, so then we can really understand how thermal energy is being used in Malaysia and inform future policy and regulation. So finally, on our agenda today, thank you all for sticking with us. Hopefully you found what we've done so far interesting. The final thing that I just want to quickly run through is our Energy Efficiency Accelerator. So this project, this workshop today is part of the UK-ASEAN Energy Efficiency Accelerator, which is our work around the region on helping food and beverage companies with their energy management journey. So Kalyani has obviously talked through today some energy management tips and practical actions. Kartik already talking through technologies. And what we do under this accelerator is provide those online tools and energy efficiency guidelines that we have shared today, with more information on the website for you to have a look at. We do capacity building or training like the workshop today, and also we provide technical assistance, so one-on-one support to companies. We're currently working with some companies in Malaysia to create case studies on energy management implementation. So if you're interested at all in this, do let us know. We can also talk to you about how you could get involved a little bit more in the accelerator. The kind of things that we offer under technical assistance are on the slide here. We do energy audits, identify project opportunities, looking at ISO 50001, supporting your company to drive towards ISO 50001, as well as potentially providing capacity building workshops, and also looking at the energy strategy and policies that Kalyani talked through earlier on today. And importantly, pointing you towards the equipment manufacturers that can provide those best available technologies that we talk about, and those who are reliable and active in the space and can provide you with the equipment that you need. So we encourage you to get in touch if you'd like to get involved in this under the accelerator. Of course, Carbon Trust has been doing this work around the world for over 20 years now, and so we have lots of expertise in different countries and can bring that expertise to your organization. So I'm now going to stop now and see if there's any questions. We haven't had any questions come through the chat recently. So if there are any, please do drop them in the box now. But otherwise, we will close out the workshop. So please do, if you have any questions, drop them into the chat box. But I do encourage you to follow up with with Carbon Trust if you have any questions particularly as well. So the email address is on the slide right there to reach out to anyone of the team about what you've heard today and whether you'd like to get involved in either the thermal energy study or the accelerator program. So all it leads me to do really is say thank you all for joining us today. We have a poll that we would like to just quickly run, and we very much appreciate your response to the poll. So if you should be able to see this on your screen, so please do poll for us and let us know how you found the workshop today, and vote with just to give us some feedback on how we did, and hopefully this can shape our content for the next capacity building workshop that we develop in Malaysia. While you're doing that, just want to say thank you very much to first of all our partners, the Federation of Manufacturing of Malaysia, and in particular their food and beverage department. And we also want to thank you for our guest speakers from Desmond and Chin, who have managed to give a bit more context on the practical side of delivering energy efficiency in a food and beverage site in Malaysia. So again, if you could all just vote on the poll, and I hope you all found today's useful, and please do reach out for any further questions. Thank you. Thank you, everybody. Kalyani, we have 60% voted. Is that enough for us?
That's
Fantastic.
good, yeah.
Thank you, everybody. I'll now end the webinar, and again, have a lovely rest of the day.